we will make a start. So hello everyone and welcome to this EIA community debate, Extreme Weather and EIA. This event has been organised as part of our work for the EIA community and it will explore extreme weather events in the UK, how they may change in the future, and the ways in which environmental professionals can or should incorporate extreme weather into environmental impact assessments to ensure that developments are fit for the future. For those of you who don't know us, the Environmental Impact Assessment community provides a forum for thought-provoking critical conversations around EIA from a science-based perspective. The community aims to connect and support environmental scientists and practitioners working across a range of specialisms involved in the EIA process, and to facilitate meaningful discussion between disciplines on the key issues facing the sector. You may have been to some of our debates before, and as you know, we really want these to be as discussion-based as possible. So please do introduce yourself in the chat and get involved in the discussions later on. You can also find out more about the work of the community on our website, and I will drop some useful links in later so you can read more about that there. So I'm delighted to introduce Jenny Pirret. Jenny joined the Met Office in 2014 and has since gained broad experience looking across timescales, from forecasting the weather for the next few days to analysing climate projections covering the rest of the 21st century. Jenny now works in a weather and climate extremes and impacts team, empowering people to deal with extreme weather in our changing world. Thanks so much for joining us today, Jenny. I'll now hand over to you.
Thank you for that introduction. I'll just get my screen sharing going. If you confirm that you can see that okay. It looks like it's all working.
Yes, all good. Thanks, Jenny.
Great. Thank you for that introduction, Ethny. So I'm here to talk to you today about extreme weather in the UK, having a little look over some recent weather events, and also a look towards kind of future projections of how these might change in our changing climate. I hope it's not controversial to say here that global average temperatures are rising. This is primarily caused by human activities like burning fossil fuels that emit carbon dioxide and other greenhouse gases. Global temperature has risen by more than 1 degree centigrade since the pre-industrial era, and each of the last 4 decades have been successively warmer than any decade that preceded it since 1850, with the last 10 years the warmest on record. This takes humanity into uncharted territory. Atmospheric carbon dioxide continues to rise, and now higher than anything the human species has ever experienced. But worrying though it is that global average temperatures are increasing, it's the extreme weather that we feel and how this changes. It's this that tends to be impactful, and not that slow increase in temperature. It's the differences like more intense heat waves, more frequent heat waves, flooding and thunderstorms, and also low rainfall. Those are the pictures we have here. Now, the Met Office has some experience in extreme and severe weather. Hopefully you've come across us in terms of the severe weather warnings that we issue when we're expecting impactful weather to affect the UK. We actually issue 8 different categories of weather warnings. You can see the list of them on the left. If you look into them on our website, you can see details like on the right. This is an old example. So this is an example of rain warnings. We have yellow, amber, and red warnings. So yellow is the lowest level, which gives you a bit more information about where it's going to be, what to expect, and what you can do. So it's through this severe weather warning framework that I'm hoping to talk to you today about extreme weather. I'm going to go through 7 of the 8 different kinds of weather warnings. I'm going to skip fog. You can ask me why if you like. And I'm going to go through that in terms of recent events, recent changes, and then future changes to each of these. Also, in the interest of time, I'm going to combine thunderstorms and lightning and snow and ice. Jumping straight into extreme heat. You may remember back last summer, the first time 40 degrees C has ever been recorded in the UK. This is the most impactful heat event the UK has ever had. There were 7 weather stations at or above that 40 degrees C, but also 46 weather stations. That's quite a lot. Met or exceeded the previous national temperature record ever seen. It was also the first time we ever issued a red warning for extreme heat since they were introduced, which was only a year previous, but it was a very extreme event. So on the right here, you can see how high the temperatures got in the UK that day. 40 degrees is kind of a dark brown colour here, but it's quite a lot of heat over quite a large portion of particularly England, but also into Scotland. And I hope you'll agree that our extreme heat warning matches quite well with where those really high temperatures were seen. A reminder of the impacts of this weather. You may remember there were house fires, notably in London. There were grass fires. Here's an example in Kent. The roads melted and parts of them became difficult to pass. We were also warned not to travel on the train during this heat wave because of buckling tracks that you can see here, but also because of the sort of heat stress of being on a train. And also, tragically, during these events, people can die during in the open water, trying to recover from the heat. So looking at those recent changes, this reddy purple graphic shows the top 10 hottest UK days on record. And as you can see, 9 of the last 10 have been since 1990. And the top 5, well, 4 of the top 5 have all been since 2019. So there's an idea that the records are getting broken for heat. They're getting broken more and more frequently in a heating climate. You can also see, if we break this down by the UK nations at the bottom, that each country has had its highest temperature record broken just in the last couple of years. Another way we can look at extreme weather like this is to run a computer model that looks at the world how it is now many times and see what the chance of getting 40 degrees C in the world as it is now is. But we can also run a sort of computer model that sees only natural emissions of greenhouse gases. If humans weren't here, how likely would it be to get 40 degrees C? And some results from a study like this show that in the recent climate we have now, 40 degrees C has between 1/3 and 1% of a chance per year. If we lived in a world with only natural emissions of greenhouse gases, that would be a bit lower chance per year. However, that builds into when we start looking at future changes. I'm going to talk about this table, which is looking at the probability of that 40 degrees C in the UK by the end of the 21st century. How likely it is depends on what carbon emissions the human race puts into the atmosphere between now and then, and we call these emission scenarios. If we go for a medium emission scenario, there's a chance that 1% or less chance becomes 6.7 chance per year of seeing 40 degrees C in the UK. And if we have a high emission scenario, that's increased to a 28.6 chance per year. So more than 1 in 4 of 40 degrees C being seen in the UK per year. Pulling back slightly away from 40 degrees C, temperatures are projected to rise in all seasons across the world and including across the UK. Within the UK, hot summer days are projected to become 3.8 to 6.8 degrees C warmer when you look at that high emission scenario. And we're also looking at an increase in the frequency of hot spells. So we expect to issue more extreme heat warnings in a future climate. Turning now to our next kind of severe weather. Sorry? Hello? Okay, I'll carry on. Someone must have just come off mute by mistake. So looking at rainfall, we're going to split this into kind of prolonged periods of rainfall, which tend to happen in the winter, and then we're going to separately look at sort of short summer downpours. Here are some examples that I dragged up from my memory. I remember there being some heavy rainfall through January down in Devon. There was also some back in Wales, but there's quite often a period of extreme rainfall. I grew up in Yorkshire, so we have this quite frequently there as well. There was an example as well back in December 2015 of Storm Desmond under the Met Office naming convention that affected Cumbria, that you might remember, some really severe flooding there and a major incident declared. during that event. So looking at the recent changes for rainfall, it's a bit harder to pick out than it is for heat because there's more year-to-year variability. So if we look here, we've got the different temperatures for each season per year, the average. You can see there's a lot of up and down going on year to year, but this black line is a moving average of those, and you can see it sort of gradually undulates as well. So as well as that year-to-year variability, there's also decade-to-decade variability. So picking out what the changes are recently depends on where those variabilities lie. However, if you draw back over the last nearly 200 years, this goes back to 1830, you can see that we are experiencing wetter winters and wetter springs on average in the UK. For summer and autumn, it's a bit harder to pick out a 200-year trend, but over recent decades, we have been experiencing wetter summers and slightly wetter autumns. So where is this going with climate change? Though it slightly depends on the emission scenario, and it also depends on the season. So on the left, we've got a low emission scenario. On the right, we've got a high emission scenario, winter at the top, summer at the bottom. And though there are some slight differences in the extent due to the emission scenario, the climate projections generally show we will experience wetter winters and drier summers. I'll caveat it now that those dry summers do come with more heavy downpours in general, but we'll get on to that in a minute. Moving on to those heavy downpours, the thunder and lightning warnings, but these quite often do come in with those short duration, so we call it sub-daily, but sort of scale of hours rainfall that happens over the UK, more typically in the summer. A few impactful events you may remember. We had some back in May this year in Devon, quite near Met Office headquarters, which caused some flash flooding from thunderstorms. You may remember 2 summers ago in London as well. There were 2 quite impactful thunder and lightning events. One of which is shown here. There was hospitals were forced to evacuate patients, and Transport for London experienced some flooding of their stations. And the summer before that, back in 2020, there's also was a big thunderstorm that affected Aberdeenshire and caused a landslide, which tragically derailed a train with the loss of 3 lives. So how has this been changing recently? I'm going to try and partition this into that thunder and lightning part and that heavy rainfall, even if they are sort of the same weather event when you feel them on the ground. So looking at days of thunder, this is a colleague of mine who has looked at the 2010 to 2019 period and taken the number of days of thunder from that in the 90s. So it's not a very long period ago. And you can see that there is an increase broadly in the north and west of the UK and a decrease in the south and east. But caveat that it varies slightly per season, but given that it's a relatively short time period, it's possible that these changes are just due to that natural climate variability that was so obvious when we were looking at longer duration rainfall. When we look at summer rainfall, during the last 10 years, UK summers have been on average wetter than the kind of 30-year average of recent years, and also 15% wetter even than the 30 years from before that. So there is that increasing trend in summer rainfall, at least for now. We project that it will go down in general. If we look at future changes now, the lightning depends on the season and where you are in the UK. You can see here we have the difference for a high emission scenario between the late 21st century and the late 20th century. You can see that in summer we are generally projecting that there will be an increase over the UK, and that in winter there's not going to be that much change over the UK landmass, but there may be some over the sea. But again, it depends where you are. I'm going to caveat this though, that this is very new science and still we're looking into it, and we'd really like more investigation into the reasons behind these changes. So this is kind of indicative, but definitely still a work in progress, these lightning projections. When we look at heavy hourly rainfall, as I said earlier, this is projected to increase both in summer and winter. There are a lot of different ways to look at rainfall when you start measuring it in terms of thresholds and return periods. But rainfall events exceeding this 20 millimeters per hour threshold, which can cause flash flooding, they're expected to be 4 times as frequent by the 2070s compared to the 1980s under that high emission scenario again. Oh. So moving on to the strong wind hazard, recent events. We only had to go back sort of 18 months now for a few hazardous events. There were 3 storms in a week back in February 2020, and these were named Dudley, Eunice, and Franklin, and that was the damage bill when it came through for the UK. Going back a bit further as well, tragically these storms can be fatal as well. We had an example in November 2021, Storm Arwen, that killed 3 people and, as the Times said, caused havoc across the country. So looking at the recent changes and future changes, the strong wind hazard really is one where it varies naturally year to year and decade to decade. So looking at recent changes is what this graphic on the right is trying to show. This is the number of days where the gust speed exceeds 40 in pink, 50 in green, and 60 in blue knots. But as you can see, it's difficult to pick out a long-term trend since the 1970s, but you could argue that it probably goes up through the first half of that period and down through the second part of that period. But that's probably because due to these natural year to year, decade to decade variability that I mentioned for the rainfall as well. In terms of the projected changes, it's quite fiddly for that reason. It depends on which season and which location you want to look at. And for windstorms, those are those named storm events that make the headlines. They are projected to increase slightly in frequency and intensity over the UK, but then different climate models can show slightly different things. So the magnitude of this change has quite a wide uncertainty on it. Briefly touching on snow and ice, you may remember we issued some red weather warnings back in February 2018 during the Beast from the East event, which was quite impactful. But even now, it feels like a winter doesn't go by where you don't have some impactful snow events. This one was from March this year, snow on the beach in the northeast of the UK. However, looking at how these will change, these have changed in recent years. This graphic is showing a decreasing number of frosty days over the years. This is the days where the temperature drops far enough for it to be frosty, in the ground in green and the air in blue. I think we can agree there's a decreasing trend there. And for snow, though we note that widespread and substantial events have occurred in recent years, like Beast from the East in 2018, their number and severity have generally declined since the 1960s. Looking towards those future changes, they're both projected to decrease. This on the left is looking at the number of frost days you get per year, and there's a general decreasing trend. And on the right, this is looking at just 2 different sets of UK projections for snowfall at the top and then lying snow at the bottom. And this is the difference between the late 21st century and the late 20th century, with the deeper pink showing a sort of greater than 80% chance of change in the amount of snow in terms of percentage. So you can see we're projecting a decrease in the amount of snow falling or lying over the UK under a high emission scenario. Oops. So in summary, we don't have to look into the far past to find impactful severe weather. There was an example from every kind of weather warning within the last 12 months. For some types of severe weather, there are clear recent changes and future projected changes. But for other types of severe weather, yeah, our confidence is limited, and it's still cutting edge science to try and work out what's happening. Sometimes the recent changes show that year to year, decade to decade variability, and picking out the overall trend is tricky. But sometimes in the climate projections, there's limited evidence. It's only from one computer model, or different models show different changes. Or as with thunder and lightning, we're still trying to understand why those changes are happening. And we'd like to understand that a bit better before we can kind of confidently say what those changes are. So I'll leave it there, and I'll stop sharing my screen. And I guess I'd like to invite questions, please.
Thank you so much, Jenny, for that presentation. Really interesting to hear, to kind of hear an overview of what we've seen in the last few years, but also think about how that might change in the future. So as you said, really keen now to open to questions. So if anyone does have a question, please do, you can either pop one in the chat, or you can raise your hand using the little reactions button at the bottom of your screen. I guess my question, Jenny, to kick things off is, you obviously mentioned that some of the kind of confidence around some of the modelling is quite variable in terms of different projections. So how do you kind of present that evidence to decision makers so that they can make decisions about resilience and things like that in the future?
Sure. I mean, I believe honesty is the best policy. Like, you kind of you say when your confidence is low, and you say how low. It kind of depends on the decision maker and what you might want to do with them, and also what their decision is. So we've done some work looking at kind of storylines of change in different scenarios and how that might impact the people. And sometimes when you follow it through and you look at different emission scenarios and you look at different levels of model confidence and everything, how much does it actually affect that end decision is a really interesting question as well. Like, if it's only going to be a little bit more money to build your sea defences a little bit higher, then maybe it's worth it given all this broad uncertainty kind of thing. So yeah, it's definitely still an evolving field, and we do our best. But yeah, like I say, try to be upfront about it. It depends what you're looking at as well. Looking at heat, you can be pretty confident that it is going to be hotter to some degree, but other variables, as I said, it varies.
And then in terms of the confidence, what kind of factors is it that goes into making some data more reliable than others and less reliable in certain other cases?
Sure. So I think it depends on when you look at a load of different climate models. When you look particularly to the future, you look at lots of different climate models. Are they all showing the same thing? Are they all pulling in the same direction? Or are actually some of them pulling one way and some of them pulling the other way? It can happen. Like, an example is sometimes with windstorms, not anymore. It used to be that some would show an increase and some would show a decrease. And you go, well, how do I make a decision when you've got the opposite situations happening? There's also kind of understanding the mechanics of why that change is happening as well. Like, global average temperatures getting warmer, therefore heat waves are going to get worse, is quite logical. But how that then feeds into rainfall changes is a bit more subtle. So yeah, so trying to understand those the mechanics and the physics of how the atmosphere works is in there as well.
That's really useful. Thanks, Jenny. And some questions coming into the chat. This year is obviously been dubbed an El Nino year. So what effect is El Nino likely to have on UK extreme weather events this year?
Oh, you're stretching me now. I thought with 2 minutes to 11 this question might come up, and I didn't quite have time to read it. So my limited understanding is that El Nino typically has effects in the sort of Pacific immediately, like quite soon, and that's probably what we'll see first. And it can take a little while to filter all the way around the planet and across the equator to the UK. There is maybe an idea that we'll have like a less stormy winter, maybe, but that is also very much a kind of long-term averages and like kind of just because you're having a less stormy winter on average doesn't mean you can't get some very impactful windstorms like Dudley, Eunice and Franklin, who all came along in a week. You could just have a bad week, essentially.
Amazing. Well, thank you so much, Jenny. It looks like that's all we have time for in terms of questions today, but really appreciate you coming in and talking to us about extreme weather in the UK. So thank you very much.